Okay. So, Amara, I'm happy to do substitution, if that's what you want to start with, or if you want to start on something else. Okay, so I can do a couple of substitution problems, and then you can do your quiz that we have with this. Okay, Erica, that sounds good. Do you have an example problem that you could share with me for that one, Erica? All right, so what we're going to do, Amara, is we are going to, with substitution, have you watched any of the videos yet on substitution? Okay. But what about the videos like in the class, in the course, like on lesson 5.05? Have you watched that video? There's if you go in the classroom and you go to content and then 5.05, there are some videos there that will help you. So the class recordings are really great, but I'm not able to cover everything in the class recordings. Oh, you're fine. Sorry, I don't know if I'm lagging for anyone else. But if you have not yet, for substitution, check out the 5.05 videos in the course. But let's go ahead and talk about how to solve this one. So this is asking us to solve this equation or this system of equations using substitution. So with substitution, we're looking for one of our variables, either x or y. We want one of those to have a coefficient of 1, or for one of them to already be by itself. So since neither of these are already solved for just x or just y, we're going to look for a coefficient of 1. So we've got on the top equation, this plus x is like plus 1x. And so we are going to solve for that variable. So up here at the top, I will first get x by itself. So we have 3y plus x equals 7. And in order to get x by itself, I'm going to subtract 3y from both sides. So now that I have x by itself, what I can do, this statement up here says that x equals 7 minus 3y, or in other words, x is the same as 7 minus 3y. So in this bottom equation, I'm going to rewrite it, but instead of putting an x, I'm going to put 7 minus 3y, because x is the same thing as 7 minus 3 times y. And then I'm going to rewrite that equation. Stormy, yes, let me look. Okay, so once we do that, we're going to now distribute. So we're going to be solving for y. So 4 times 7 is 28. 4 times negative 3y is negative 12y. Yep, you have 28, good. Minus 2y equals 0. So we're going to combine like terms. So negative 12y minus 2y, what would that give you? Yep, negative 14y. So we would get 28 minus 14 times y equals 0. And then we're solving for y, so we're going to subtract 28 from both sides. So negative 14y equals negative 28. We are going to divide both sides by negative 14. So we get that our y value is equal to 2. So y equals 2. So that's our y value. With systems of equations, we're looking for an x value and a y value. So now that we have y equals 2, we're going to go back to our original equation. So 3 times y plus x equals 7. We know that y is equal to 2. So instead of writing a y, I'm going to plug in that value of 2. So 3 times 2, which would be 6. 6 plus x equals 7. I will subtract 6 from both sides and get x equals 1. My final answer, I'm going to write it as an ordered pair. So that would be written as, you write it in parentheses, 1, 2. Hey, Stormy, will you go to slide 7 on 5.06? I want to show you something. Okay, awesome, Omar. If you want to, if you have any other questions or you want to do another one, we can. Just let me know. There is no 5.5. This says 5.5 videos. There's no class kick for 5.5. It was just a quiz. Okay, Stormy, I see you here. So, my question for you is, did you add or subtract? Did you add or subtract these two equations? Okay, perfect. That's what I thought. So we want to make sure we put our put our subtraction sign in there. Oh, wait, you added? Oh, okay. Yeah, so when we add, nothing cancels out. But because we have 4 and 4 and both are positive, we're going to subtract. So when we subtract, this first one, the x's, is 3 minus negative 2x. So do you see how that becomes a positive because it's subtracting a negative, which becomes 5x. So go ahead and adjust your numbers here. In this row, go ahead and adjust those numbers. And then don't forget, since you're subtracting, this should be 18 minus 8. I think you did plus 8. Okay, Adelina, is this on a homework or something? Let me write this problem on the whiteboard so I can help you. Adelina, is this a quiz question? That's fine. I just was asking, that's all. Because I can get you started. So let's use, we can do x plus y equals 4. And then does that one say, okay, and then let's do x minus y equals, let's try 8. Okay, so both of these problems here, equations, we have 1x and 1x, or we have 1y and negative 1y. So you can do either operation. You can add these together and cancel out your y's, or you can subtract and cancel out your x values. So what would you like to do, add or subtract? Good, Stormy. We're going to add them? Okay, that's great. So if we add these together, put a big plus sign here, x plus x, so 1x plus 1x is 2x. We have y plus negative y, so those are going to cancel. And then we have 4 plus 8, so that would be 12. And then when you divide everything by 2, you would get x equals 6. So the x value will be 6. Now, once we have the x value of 6, we have to come back up here to our original equation. And instead of x, we're going to plug in 6. So 6 plus y equals 4. And now we have to solve for y. So y is going to equal negative 2. So then our answer as a ordered pair is 6, negative 2. Yeah, you're welcome. Does anyone else have any questions or problems that they'd like to go over? Okay, Erica, what was your question? Oh, the multiplication one. Do you have an example for me?
No, I couldn't find an example.
Okay, you just think you're confused, or did you miss a problem on something?
I was just confused on how, like, the steps of how to solve the problem. Like, I had got it, I had got some correct on the quiz, but it was just like confusing of how, like, the steps.
Okay, let me look at your quiz and see. Amara, I will look at. I'll pull up 5.6 homework for you in just a second, and we'll go over some. Let me look at Erica's quiz real quick. Okay. Hang with me, Erica. It's just taking a little bit to get loaded. So, Amara, with 5.06, we are doing elimination. So I'm going to go back to our slides here. Okay, let's look at. Okay, pulled up your quiz. Wait, Erica, you got 100%. Let me see if I can figure out. Okay, so Erica, I can do a quick one with you, but you got 100% on this one. So I'm not sure like what problems to go over with you because it seems like you kind of get it, but let's try. I can just like sort of do an example, I guess. I don't have any on the top of my head, but let's see.
I have an example on the quiz that I was confused about. Here.
What number was it?
I'm pulling it up right now.
Probably number 5. Does it have fractions in it?
Yeah, number 5.
Okay. So when you have a problem where everything has a fraction. So for example, in this first equation here, everything, the fractions, everything has a denominator of 2. Okay. So when you have a denominator of 2, you can get rid of that denominator by multiplying everything by positive 2. Then they cancel. So what we're going to do here is multiply everything in this top equation by 2. Okay. So when we do that, we would get 7 halves divided by 2. So 7 times 2 would be 14. 14 divided by 2 would be 7. So we'd get 7x minus y equals 9. Because these are going to cancel this 2, this 2, this 2, this 2. So then here's your new system of equations. So I've got negative y and negative y. So I'm going to subtract, okay, because this would be negative y minus negative y. So now that becomes plus, which is 0. Does that make sense?
Yes.
So when you have we have a bunch of fractions in your equation, you're just going to multiply by the denominator to get rid of all of those fractions.
What if it has different denominators of the equation? Do we just do the same thing? Multiply it by...
You shouldn't have any problems like that. But if it does, then you can go ahead and pick one of your equations, one of your variables to solve for. So you could try to solve for x and try to solve for y and go that route. You might just have some fractions as your answer for your solution.
Okay, thank you.
No, not necessarily, Jonathan. But you can use substitution. You could graph these if you wanted to, but sometimes elimination is it's not the best method. It's the easiest method because you can eliminate the fractions right off the bat. Okay, let's look at 5.06. So Mara, this goes over some problems of elimination. So if you want to go ahead and go to slide 3. Sorry. Okay, there you are. Alrighty. So we have x minus y equals 39. And then, x plus y equals 51. So with elimination, we're looking at the coefficients of our variables. So the coefficients of x, we have a positive 1 and a positive 1. When the coefficients of one of your variables are the same number, in this case 1, and they're both positive, we would use subtraction. This one's kind of unique because the y's have coefficients of 1 also. 1 is positive and 1 is negative. So when you have opposites, you can add. So you can decide, you can let me know what you prefer. Would you like to add these two together or subtract? Okay, let's add them. Adding is usually easier. So 1x plus 1x is 2x. -1 plus 1 is 0. And then 39 plus 51 is 90. So now you're going to go ahead and solve for x. So that means you're going to be dividing by 2 on both sides. Yeah, it's pretty much all the same thing. Same steps. Once you get x, the x value for 45, then you're going to go back to your original. So you can do x plus y equals 51. And instead of x, you're going to put in 45 and subtract by 45. So it's not too bad. It's just a different way of solving systems. But the second part's the same. So once you get one variable solved for a number, like x is 45, then all of the rest of them are the same steps after that. You're just plugging that number in for x and then solving for y. So yeah, it's not too bad. Yes. So for all of 5.6, you're either going to be adding or subtracting the top and bottom equations. What other questions do y'all have? Anybody else have questions? If you have no questions, you're free to go. Yes, I think yeah, we can. Okay, so I think we've done this one a couple times, but we can like kind of work through it. Okay, so which one of your variables are the same? The x, or which one of your coefficients are the same? The coefficients of the x variable. Wait, are you talking? Okay, yeah, you are. Okay. So which one of these is the same? The x values or the y values? Just looking at the coefficients. The y values. So these are the exact same. Okay, so when you have two y values that are the same, subtract. Okay, so we're going to subtract these two equations from each other. We have to be careful with this one because of the double negative. So this is 3 minus -2, which is really 3 plus 2. These are going to cancel, 4 minus 4, and then you'll get 10. So I'll let you go ahead and finish solving that one. Yeah. Well, my advice to you is please make sure you go and watch all of the content videos in the individual lessons. The recordings are good, but they're not as helpful without the content videos because I don't cover everything in the recordings. And I don't think I got to elimination last Tuesday. So just make sure you give those a peek at some point. Let's see. What else do we have? What other questions? Awesome. Thank you. So linear combination is the same thing. You just might multiply by one number. I can see if I have any examples from that. Sure. let's go back to, I can show you the one I helped Erica with, and then I'm going to have you go watch those videos because that has like a full in-depth teaching. Okay. So this was one of the linear combination ones. When we look at our variables at the beginning, the coefficients in front of x are 7/2 and then 3. So those are not the same numbers, and they're not opposite numbers either. So then we're going to take a look at the variables in front of y. So we've got -1/2 and then -1. So again, we do not have the same variables. When this happens, we may need to get rid of, we need to make some of the numbers the same. So when you have a fraction, like these are all 7/2, 1/2, 9/2. When that happens, you're going to multiply by the number in the denominator, so the bottom number. When you multiply by that denominator, it cancels out the fraction part. So you're just left with the numbers on top. And then once you do that, now we have -1y and -1y. So now we have the same coefficient. So what we're trying to do is find a number that we can multiply the entire equation by. So that way we have the same coefficient either in front of x or y. The 5 didn't become a 9. It should still be a 5. I think I just wrote the wrong number there. It should still be 3x, equals 5. Thank you. So then this one you would subtract because you have -1 and -1. So they're the same. So we subtract. So you would get 4x equals 4. Yep, exactly. Mm-hmm. I think so. That sounds about right. don't think it'll be too bad. So, Anaya, what did you get for X? Let me go to your 5.6. So, Anaya, go ahead and finish on the left side here. Go ahead and finish solving for X. Yes. So make sure you draw your division sign so that we know what you're doing. That way you don't get confused. There you go. Okay, good. So X is 2, perfect. And then I'm going to get rid of this. So what you're going to do is take this top equation and you're going to rewrite it over here. But instead of X, you're going to plug in 2, since that's what your X value is. I mean, instead of writing a 2, instead of writing an X, you're going to write a 2 like we've been doing. So I can show you what I mean. So on this problem, we found that X was 6. So up here, this is my original problem, X plus Y equals 4. Instead of an X, I put in a 6. So you're going to have to plug yours in using parentheses because you're multiplying. That says 3. Yep, there you go. 3 times X. So 3 times 2 plus 4Y would equal 18. And then go ahead and do 3 times 2. So now you're just going to solve for Y. Good job. Keep going. Okay, so we can't add 6 and 4Y because 6 does not have a Y. So remember, we're solving for Y. So we need to move that 6 away from 4Y. Oh, that sounds good, Amara. All right. Well, you enjoy those apples. Yum. Bye. Have a good day. Okay, so how are you moving that 6, Anaya? Go ahead and don't forget to write out. Like when you move things, you have to write if you're adding, subtracting, multiplying, or dividing. Good. Bye, Adelina. Good. So keep going, Anaya. Good. So, Anaya, how did you move that 6 over? Like, read this part right here to me. This says 18 what? Does that say 18 minus 6 or 18 plus 6? Minus. Okay, so what is 18 minus 6? Yeah, there you go. 12. So then keep going. You got one more step. Good. there you go. You got it. All right. Well, thank y'all for coming. I hope you got some questions answered, and I will see you in class tomorrow.